Hello, mentors. Let's take a look at how many symmetries. So this is in part 1 of meeting 4, right after the codes activity, right? The nicknames and the codes. So the teams will get several shapes and they need to place them in each of these 4 categories or quadrants, depending on the number of symmetries that they have. So it's exactly the same that we did here from 0 to 3, but instead of letters, now we have, well, more complicated shapes, right? The symbols. So let's take a look at the solutions and how it looks like and discuss. Before you start, all the teams should predict which category will have more elements, or more general, what's going to happen. So some kids or teams would say it's going to be even, kind of, maybe, yeah, 25% or so. Some kids will say, I bet there's a lot of shapes without symmetries just because they can be random. Some saying, I bet these shapes, whoever created them loves symmetry, so I'll have a lot of them. Some kids may say this is going to be empty if they already know or suspect that the 2 is impossible. And some kids will also say that there's going to be a lot in 1 because there's several ways a shape can have 1 symmetry, right? Because there's 3 symmetries, where there's only one way you could have 3 symmetries, which is having 3 symmetries. Same for no symmetries. So they predict a lot of action in this 1 category. So let's take a look at the solutions and the final categorization. So first, you would have shapes without symmetry, no particular directions like this. This is a little hard because it looks like there's some symmetry, but if you rotate, you have 2 cards, the teams, so they can rotate or try to flip, you'll see that it fails. Same for this one, for example, if you rotate it, yeah, it's not the same shape. Same for this. And this is almost rotational, almost if you rotate, but the width of this S is not the same. It's not uniform, right? It's thicker here on the top part, but you can tolerate, so you'll have a discussion. So let's try to have this discussion here. This is what's going on. You have this S, and when you rotate it, you almost get the same shape. I mean, generally it's the same, like 3 shapes here, also 3 here. So it depends on your tolerance. I put this analogy, if you say that it's 6 p.m., but it's really 5:58 p.m., are you correct or not? Are you lying or not? Well, it depends, right? I mean, it depends on your context, on the situation. If you're really tracking an experiment, like a time experiment, or doing something really time sensitive, then it's not 6 p.m., it's 5:58. But if you're in a more social and relaxed context in which 6 p.m., it's a good approximation, then yeah, you're right. It's fine. It's useful to say that it's 6 p.m. So it all depends, and it's a nice discussion to have. So some other shapes have also this kind of property, but this is the most interesting. But for the most part, all of them should be sort of okay. So no symmetries, you have 5 shapes. Just 1 symmetry. First, those that have vertical line, of course, the heart, it's easy to see this as just 1 because flipping it with the horizontal line would change a square and a circle. This is kind of subtle, but I think it's significant, and it's clear, right, that the circle and the square are meant to be different, whoever created the art. Whereas this, you kind of suspect that it meant to be kind of a rotational thing, and it just failed at the last moment somehow. Also vertical, a triangle. This is also just vertical and not horizontal. And this is also vertical translation. Just rotational. This really, really nice. What happens when you rotate it? You get exactly that. And it's not horizontal, but it's something happens that's very nice, that you kind of complete it when you do the horizontal or vertical reflections. This is rotational, very, very nice also. Same for this, these triangles match. So to justify this, you could ask the students to kind of start matching triangles that would rotate to each to the other one. So you identify these pairs of triangles along the center line. This we also know that if we flip it vertically, these diagonals would change, right? So that's why it's not, but if you rotate, it's perfect. You get exactly the same shape. And finally, this also allows for some rotation. Again, some students may say that it's 1 millimeter off or so. So you would have this discussion and try to convince them that, okay, let's place it here. And we understand that for this context, we tolerate some very minimal error. Although they're right that if you want 100% precision, then you may run into some trouble. Oh, sorry, before we continue, some kids may wonder why there's no H-line rotation. And this is just because of the set we gave. So this is also another nice discussion to have. They could quickly draw shapes to have this rotation, or they could also say, hey, whatever of these of these B lines, if we rotate them 90 degrees, they would automatically have the horizontal line. So they're deeply connected, right? So you could also explore that direction. All symmetries, things that look like squares or like circles somehow, or like flowers, things that are very complete, right? In a way. This is the king of all the symbols. This looks like a soccer ball to me a little bit. And this would, kids may first say that it just has vertical, but it also has horizontal symmetries. Same for this one. I think there's some millimetrical mistakes, like very, very errors if you really zoom in. But I would place it in all symmetries. I think that's the spirit of the designers of this logo, right? Of this icon or symbol. What happens absolutely is that, and here's no question about it, this is absolute, that it's totally impossible to have shapes with two symmetry, because any of the two symmetries of the three that we consider will imply the third one. And that's just because if you do any of these of two, you get the third one for free. So that's good to illustrate and say, for example, you could say that if it already has a vertical line or a horizontal line symmetry, it will change, and a rotation and it doesn't change, then to get the other symmetry, you would have to do the other two transformations. And if you didn't change in those two, then you don't change in the last one, right? So that involves some explanation similar to some of the content of the previous meeting 3. And that's it. That's the final classification. We'll have cheat sheet. We'll have this sheet for you during the meeting so that you can have it to check for things, but really practice with your commenter and also with yourself, and try to get an intuition of the shapes, right? Especially, I guess, this telling apart these two, how rotation works, that you have these diagonals or these lines here, diagonal lines, and that it's only vertical line. Okay. So see you in the next video. Goodbye.